Rule number 2.
Except it's not really a written rule, it's more a method.
More of a method, absolutely. It's called integration by substitution, and it's based on the chain rule of Joseph and Nazareth and all that.
Yeah, good differentiation.
Yeah.
But now with integration, you've got to do a few jazzy things that are brand spanking new.
Yeah, dogs love it.
Kids love it.
Your grandma fit in the boot.
Stop selling me cars.
Sorry.
I've already got enough.
Okay.
So, we've got a nice example of it.
We have got a nice example, so I'll read it out for you. We have integral, so it's magic snake, 2x, open bracket,
Oh, here we go.
x squared plus 1, close bracket, to the 5 dx.
Oh my god.
It looks horrendous.
And it isn't that much better. We'll go through it anyway.
Absolutely. So you can see already why it's based on the chain rule because of the thing.
Yeah, it's got 2 products, so this one's in the bracket, so it's going to be a chain rule.
Yeah. So,
we start in a similar way. We make u equal to the thing in the bracket. So we can say u equals x squared
plus
1. But now, because it's integration, you can't do what you would do in the chain rule for differentiation and say y is equal to 2xu, because it's not differentiation.
No. But you then differentiate u.
Yes, we start integration by differentiating.
Yeah. And there's a reason for this, but we'll go through in a second.
So this would be du by dx.
It would be du by dx, and this would give us 2x.
2x.
Because the 1's dying.
Okay, now we have to do something quite jazzy with this.
Very jazzy. So, we don't actually want any V's or any X's, we just want everything in terms of u.
Yeah, because then it's easy to boil it down and integrate it.
Yeah.
So first we're going to say that this is the same as du equals
2x times dx.
So if we go back to our original equation, it can be written in a different way because it's multiplication. It can be x squared plus 1 to the 5 and then
2x
2x
dx.
by dx. Now this part looks awfully familiar.
It does, it looks a bit like what we've got here.
In fact, we can go ahead and put that right in there.
Yeah.
And this bit, I think we've already decided was u.
I think we did decide it was u.
So u to the 5
absolutely.
by du. We're just replacing that with du, and we've already said that that's equal to u. The
Absolutely.
reason we do this is that can be integrated, this u by du. That's what it means, is that you can then integrate this with respect to du. So, let's do it.
Then we go ahead and integrate it, so we increase the power by 1 and divide by the new power, so it becomes a sixth of u to the 6 du.
Of u to the 6 plus 6, like that.
Yeah.
Then we can go ahead and put u in back as it was, so it's going to be a sixth
Lots of x squared plus 1.
Now raised to the power of
6. Yeah.
Now if you look at that, and you were asked to guess an integral, never in a million years would you have said a sixth is the coefficient.
Probably not.
Almost certainly.
Almost certainly not. But there's a little confusing, and this is probably one of the harder bits.
Yeah, I would say so. You've got to get a u equal to a thing in there because it's applying the chain rule, then differentiate it. Then you want to integrate with respect to u, because respecting to x there's just too much going on.
There's too
It's
much going on.
hard.
So this bit is the most important bit really. The 2x being the same as your 2x there. If it's not, if that was say 4x.
Yeah, if we'll change it. If this was 4x, then you'll notice when we get to this stage, I'll just rub all this bit off, and we write it back up, this would be 4x dx.
Which isn't the same as 2x dx, but it is a factor.
So it's easily sorted. If you put a half
In front of your
on
entire
that side,
thing,
and
you
then
just
put this to 2x, like that,
then it's sorted.
it's the same thing. So you can go ahead and put in your du here, and so on.
Yeah, and then continue as n, and then put the halves in right at the end.
And there you go.
And there you go. That is a bit confusing, but that's rule number 2. And now without further ado, I think rule number 3.
I think it's essential.
Yep,
Let's go.
that.